All right, so this video will be about the homework last night, just a review to go over the answers so you can use it for your reference sheet. All right, so we looked at distance problems yesterday, and there's really a few different types. Okay, there's the ones where somebody's traveling up and downstream. There's the ones where people are traveling 2 points and they're going to meet. And then there's the ones where two people start at the same spot and one person has a head start and the other person catches up. All right, so we'll look at a little bit of both. I think the first one is the current. The next one is a catch-up problem. Okay, when do they catch up? Let's see, this one is about a rate, so we'll look at that one. And this is about when two people are going to be a certain distance apart. All right, when we solve them, we're going to set up a system. And what method do we always use to solve it? Do we use elimination or substitution? Substitution. All right, so the tricky part is just getting our table. Okay. It says a motorboat makes a trip upstream, and then it's going to come back downstream. All right, so first thing we want to do is figure out the two things here. Okay. Two things I would probably write are motorboat makes a trip upstream, and then to make the trip back, okay, we could call that downstream. Okay, so let's put in those two things. Upstream, downstream. Now, when you go upstream and then you come back the same way you came, what do you know about the distance you traveled? If you started, say, at your house and you traveled upstream and then you traveled back to your house, how does the distance going upstream and downstream compare? Yeah?
One's faster.
Not the speed upstream, just the distance you travel. Like if I go from here to Boston and then I go Boston back to here, how do those distances compare? Yeah? It's the same distance. Okay, so anytime you do an upstream, downstream problem, the distance is the same. Okay? So put in a D and put in a D. The thing that's tricky about upstream and downstream is the rate. Okay? You have two things you have to put in the rate box. Okay? When you're traveling with the current, you go faster. When you travel against the current, you go slower. Okay? So you have the speed of the boat. And do they give us the speed of the current? Makes an upstream trip in a current that runs at 2 miles an hour. Yeah, we have the current. So when you go upstream, you're fighting the current. So does that slow you down or speed you up?
Slow you down.
Yeah, so when you go upstream, the current is fighting me. It's going to slow me down. Okay, the operation we use for slowing down, going slower, we're subtracting from our speed. Okay. Now when we're going with the current, okay, it's going to push me along. So that means I'm going to go faster. So I'm going to add to my speed. Right? Now the last thing I have to do is look at the problem, and hopefully they have some times. It took the boat 3 hours to go upstream. Okay? 3 hours to go upstream. All right, so 3 hours to make the trip upstream. Does that go in the top box or the bottom box? Top box. 2 hours to come back. Okay, so where does that go? Bottom box. Okay, that's it. That's the hard part. Okay, now we got our equations. Basically, just put an equal sign right there, and that's equation 1 in the top box, equation 2 in the bottom. Okay, so let's write equation 1. D equals, what do I want to make sure I do with the r minus 2? Put it in parentheses. And same thing with the r plus 2. D equals r plus 2 times 2.
What if you put it the other way? What if you put equation 2 as equation 1?
That's okay. Yep. If you switch these, that's perfectly fine. You just got to have both of them there. All right. And now the method we always use is substitution.
I have a question. Like the 3 outside of like the parentheses, would you be allowed to put plus 3, or would that change the answer?
No, it's got to be times 3.
Okay.
Yeah, if you put plus 3, that would change the answer.
Okay.
Mhm. All right, so now we're going to do substitution. It says D equals that, R minus 2 times 3. Do I have a D in the bottom equation?
Yes.
Yep, I have a D right there. So we're going to fill in, using equation 1, into equation 2. Okay, that's the substitution part. Okay, let's just write that out. So we got R minus 2 times 3. Okay, fill that in for D. And now just copy down the right-hand side. R plus 2 times 2. Okay, what property do I have to do on both sides? They say, yep.
So like make it so it's like negative 2y, right?
So we have this 3 on the outside of parentheses. Distributive, yep. We have to distribute the 3 and the 2. Okay, so I'm going to do that part for you guys. 3 times r is 3r. 3 times negative 2. 2 times r is 2r. Again, you're going to practice more of these on your own. I want you guys to have the answer nice and neat here. And then 2 times 2 is 4. Okay, next thing I would do is plus 6 on both sides by adding 6. That's going to get rid of the negative 6. And I get 3r equals 2r. What's 4 plus 6? 10? Okay, last step. Move the 2r to the other side. And we're going to move it by using subtraction. 2r, 2r. 3 take away 2 is 1. 1r equals 10. And that's it. That's the problem. Okay? So it doesn't seem too bad, but you just have to set it up the right way, and they're all about that difficulty, if you can figure out how to set it up. That's 10 miles per hour. Okay, so on the test, I'm going to have you come back up and then write the speed right there.
I want to see what it is.
Okay, so now everybody should have a nice example of a upstream and downstream.
Not a meeting. Oh, sorry.
Just be careful. Any questions on that? All right. Okay, example 2. It says, on a bike trip, we got somebody riding at 6 miles an hour, somebody else at 7. Okay, and this is a catch-up problem. Okay, so somebody's leaving before the other person, but then they're going to catch up to each other later. Okay, my 2 unknowns here. Okay, what are my 2 unknowns?
George and Paul.
Yep, so we could put George and Paul. And they're going to catch up to each other. Okay, so they're both going to start at the same point. Okay, let's say they both start at point A. They're both going to end at point B. So if George starts at point A and gets to point B, Paul starts at point A and gets to point B, what's the same there?
The amount of distance they...
Right, they're each going to travel the same distance. Okay? Now, one of them might do it faster. Okay? In fact, we know one of them is going to do it faster. But they're each going to travel the same distance. Right? So once you figure out what's the same in the problem, put that letter in both spots. Okay? Distance is the same, put a D in both spots. If time was the same, I'd put a T in both spots. All right. As I read this, George rode his bike at 6 miles per hour. What box does that go in? The 6. Rate, and does it go in the top box or the bottom rate box?
Top one.
Top one. Okay. Next one. Paul, we'll worry about this part. Paul began an hour later. Paul rode at 7 miles an hour. 7 goes in the bottom box. All right. Now, the last piece of information we have to look at. 1 hour later, Paul began the trip. Okay.
Would it be t plus 1?
All right, we could either do a t plus 1 or a t minus 1, depending on where we put t. Okay. Do you guys want to put t by itself for George or t by itself for Paul?
T by itself for George.
Okay. So if we put George as t, it says Paul began riding an hour later. So how would you represent an hour later? Okay. Think like if I rode 6 hours and you started an hour later, it would be 5 hours. So think, what do you do to 6 to get 5?
I was going to say t plus 1, but would it be minus 1?
It would be minus 1.
Also, that's where I missed it.
Think about it this way. Paul began after George. If he began after, did he ride longer or did he ride shorter? Shorter time. If Paul began after, it's shorter. Think, what operation is smaller? What operation is lower, shorter? That's minus. And that's it. That's our setup. Okay. Just put an equal sign. Put an equal sign. And now write your equations. Okay. Equation 1. D equals 16. Equation 2. D equals 7 times t minus 1. I just want to make sure that I do the t minus 1 in parentheses. Okay, top equation says d equals 6t. Do I have a d in the bottom? All right, sorry, do I have a d in equation 2?
Mm-hmm.
Yep. So you're going to fill in what d equals in equation 2. Okay, and then we solve it. So 6t equals 7 times t minus 1. Now, what do I have to do next? I only have to do it once. In the last problem, I did it twice.
Distribute.
Yep, distribute. Okay, I'll do that part. So we've got 7 times t and 7 times negative 1. Okay, let's bring the 7t to the other side. So subtract it. Okay, be careful here. 6 take away 7 is how much? Negative 1t. And last step, how do you get that negative 1 on the other side? Divide. Yep, and I heard somebody say it's going to come out to a positive 7. Which makes sense because time should never be negative. Okay?
So anytime you get a negative answer for a time problem,
Yeah, if you get a negative answer, something went wrong. Yep.
How are the problems just not right?
Or there could be a mistake in the problem, but Mr. Roy and I will double check the ones in the test. So hopefully there won't be any mistakes. Okay, and I think this should say, not Jim, it should say George.
George. I mean, why
Oh, so George has been riding 7 hours. Okay, if George is riding 7, how many hours was Paul riding? 6. Paul left an hour after and caught up. So Paul went a little faster, and he only had to ride for 6 hours to catch up to Jim. And that's the second one. Okay, any questions on that one? Okay, so hopefully maybe it starting to make a little bit more sense, but again, you're going to get to practice on your own as soon as we finish up the last 2. Does anybody still need to copy anything here? All right. Anyone else? Okay. take a look at example 3. Okay, example 4 looks like it's another catch-up problem. Okay, we're going to be catching up. All right, but let's do 3 first. 2 airplanes left from the same point. Okay. It says one plane was traveling 450 miles an hour. The other one is traveling 600 miles an hour. I want to know, when will the planes be 2,100 miles apart?
That's a lot of numbers.
Yep, it's all on the numbers, so we got to organize it all into a table. Okay. Does everyone see why the planes are getting further and further apart? Because one plane is going faster than the other. Okay, so think about it. If you and your friend both left from the same point and your friend is always going faster than you, he's just going to get further and further away from you, right? If you don't increase your speed. All right, so let's call these plane 1 and plane 2. Plane 1, plane 2. Right, and we know the speed of each plane. What's one of the speeds of the plane?
450.
One plane is traveling at 450. It does not matter which plane you say is 450. Plane 1 or plane 2. Doesn't matter. Okay. The other plane is 600. Now, the next part a little tricky. We've got to figure out what's the same. Is the distance that each plane travels going to be the same, or is the time going to be the same?
The times.
The time, right?
Because one's going faster, so it's going to be farther.
Yeah, one of them's going faster, so it's going to go farther. So the distances are not the same here, but the times will be. Okay? It's like if I drive 60 miles an hour and you drive 30 miles an hour, and then I say, where will we both be in an hour? Well, an hour's gone by for me, an hour's gone by for you, but I've traveled farther because I'm going faster. So the distances are not the same. All right, so now we just need to figure out how we're going to represent our distances. There's one number we haven't used in this problem yet. 2,100. All right? What letter do we usually use for distance? D. Okay, so we've got to let one of these planes be D. Okay? Which plane do you think is going to travel farther? Plane 1 or plane 2?
Plane 2.
Yeah, so
Faster.
because it's going faster. So let's just say the distance plane 2 travels is D. We don't know how far, but we know it's going to travel D. Okay, now let's draw a diagram. We want to know when the two planes are 2,100 miles apart. That's what we want to know. And we know one of them is going to travel farther than the other. So let's say maybe they start right here. Right? So that's where the planes start from. One of the planes is going to travel farther than the other one. Okay? Which one travels farther, plane 1 or plane 2? Plane 2. Okay, so let's let this section's like plane 2. This section's plane 1.
Wait, but then the plane 1 started before the start line then.
They both started from right here. That's the airport. They both took off from that point right there. Right, so that's your airport.
I think we said last year that subtract the distance apart from the thing that was going slower.
Yep.
I thought we said that.
Yep.
Because even me, I have a hard time understanding the whoa. So when you have a question like this, subtract the distance apart from the thing that's going slower.
All right, so the plane 2, okay, how far is plane 2 going?
Plane 2.
What do we label it as in that box? D. So this section is D. Okay? Now, Mr. Roy just gave you a hint. We have to figure out what this section is. That's what's going to go in this box. Well, let's say you're driving with a friend, right? You want to know when you're 2,100 miles apart. if you drive D miles and you want to get rid of that part and say, all right, how far is the other part? What would you do to get rid of the D part? What operation? Yeah, if you subtract it from the 2100, that tells you what's left. Okay, simpler example, let's say we want to drive 50 miles apart. If I drive 10, how much do you have to drive? 40. 50 minus 10. Okay? Let's say we want to drive 100 miles apart. If I drive 10, you have to drive 90. 100 minus 10. So you take the total distance and subtract D. Okay? So 2100 minus D. Okay, so that's a little tricky to set up. Now just put your equal sign in, and there are your equations. Okay, let's just write them down. 2100 minus D equals 450 T. Equation plane 2, D equals 600 T. Okay. Which equation has a letter by itself? Equation 1 or equation 2? Equation 2. It says D equals 600T. Do I have a D in equation 1?
Yes.
Yes, I do. Right there. So we're going to take and fill in using substitution for D. Okay. Let's write it out. Let's move on
Wait, we're
up.
substituting what now?
We're going to substitute 600T into the top equation.
Oh.
Okay? You always take whatever's by itself and fill that in for the letter in the other equation.
Okay.
2100 minus, don't write D, fill in 600T. Okay, now I'm going to have 2 steps. First step, I want to move negative 600T to the other side. So I'm going to add it. And I'm going to add it. Can anybody tell me what 450 plus 600 is?
It's 1,050.
1,050, thank you. And now, how do I get rid of this 1,050?
Divided?
Yep,
Divide both sides by 150. I mean 1,050.
divide by 1,050. Okay, 2 seconds. Yeah, I think that comes out to 2, but let's just double check. 2. Right, so T equals 2. And on the test, I'm going to have you copy that back down into the box up above. After how many hours will the planes be 2 miles apart? 2 hours. And that's correct. Any questions on that one? All right. Last one. Okay, so it says, at what rate did a train travel to catch up with a bus in 2 hours? All right, so we know something about time. If the bus traveled at 60 and it left an hour before the train. All right, that's a tricky one. We got to think about it. Well, I know I have a bus and a train. That's a good start. Okay, this is a catching up problem. What's always the same in a catch-up problem?
The distance.
The distance. Good. Anytime you're catching up, you're each traveling the same distance. So what do we put in both distance boxes? D and D. It says the bus traveled at 60. Where's that going to go?
Rate.
Rate, which rate box?
Top one.
Top one, the one for the bus. All right. Now it says, at what rate did a train travel to catch up with a bus in 2 hours?
Wait, so it's catching up with the bus in 2 hours? Like it takes 2 hours to catch up, right? That's what it's saying?
Well, let's read it carefully. At what rate did a train travel to catch up with a bus in 2 hours if the bus traveled at 60 and left an hour before the train? So the train is catching up in 2 hours. Okay, it takes the train 2 hours to catch up.
So 2 would it be like T minus 2 or something?
Well, I think we know a number here we can fill in. What number do we know? 2. And it says the train traveled 2 hours to catch up with a bus. That's how I would word it. It sounds a little easier that way. Okay, so the train traveled 2 hours to catch up with the bus. Okay, so we know that. Now, it says, what does it say next? It says the train, the bus traveled at 60 and the bus left an hour before the train.
So would you do 2?
So what does that mean? The bus left an hour before the train.
So 60 minus 12.
Let me make sure I read that right. At what rate did a train travel to catch up with a bus in 2 hours if the bus traveled at 60 and the bus left before the train? So if the bus left before the train, which one was on the road longer? The bus. The bus left before the train, and it was on the road an hour before.
So it'd be like 2 plus 1? 2 plus 1.
So the bus has been, so how long has the train been on the road?
2 hours.
Careful.
3.
Let's go back. Which one has been on the road longer?
Wait, wouldn't the 2 be on the train because the train traveled 2 hours?
Well, the train, I don't think it said the train traveled 2 hours. It said, at what rate did a train travel to catch up? I hate the way this is worded. What rate did train travel? I think you want the 2 under train. I think you're right, Rose. The train traveled 2 hours to catch up with a bus. Okay? Now the bus traveled at 60 miles an hour and the bus left before the train. So if the bus left before the train, how long has the bus been on the road?
13 hours. Oh, an hour. Yeah, because 2 minus 1 is an hour, right?
Well, guys, you've already come to the point where you know that the bus has been traveling longer than the train, right? So the amount of time that the bus has been traveling has to be greater than what number? Justin?
Is it 2 plus 1?
2 plus 1, right? Because it left an hour. The train's already been on the road for 2 hours, right? But then the bus leaves an hour before that. So the bus has been traveling how long?
3 hours.
3 hours. Good.
Yeah, these problems are the trickiest just because of the way they're worded. There's no way you can really word this clearer. It's a tough problem to read. I think the other 3 were easier, but it's tough to read it.
Then what do we have to figure out the rates?
So-
the train rate would be R, right?
Yep, and the train rate is R.
And guys, these ones, like I said, these ones are tough because it gives you the amount of hours, but you have to figure it out in your mind. It doesn't say the bus has been traveling 3 hours, the train's been traveling 2. It says it leaves an hour before.
Would it come out to the same answer if you just put 2 plus 1?
Yeah.
Okay, yeah, that's what
Yep.
it said.
So now set up your 2 equations.
Yeah, but like
Okay.
2 plus 1, yeah.
Distance equals 60 times 3. What's a little different here is I can actually find that number. I'll do it in a second. And distance equals, instead of R2, how do you think I'm going to write that?
R times 2.
2R.
Oh,
Okay? Now, in the top equation, it says distance equals 60 times 3.
But we substitute that in for the D on the bottom one.
You're going to substitute that in for D on the bottom one. Okay? What's going to be nice, though, is you're not going to have a letter when you do that. It's going to be an actual number. All right? So distance equals 60 times 3. Plug that into the bottom one for D. 60 times 3 equals 2 times R. What's 60 times 3? 180. And my last step, what do we do to finish this up? Divide by 2. So R is how much? 90. Okay, so what's the speed of the train? 90 miles an hour. Okay, does that make sense? Why does the train have to go faster than the bus? Look at the times. Right, because the train, it's leaving after, so the train has to catch up. Okay, the train is only on the road for 2 hours. The bus is on the road 3 hours, but they each go the same distance. Okay, so it's like if I have a head start on you, and I'm going to Boston, and we end up getting to Boston at the same time. If I had a head start, you must be going really fast to catch up to me. Right? That's how the train catches up. Right? So now, at least you guys have a good example of each type of problem for the test. If there's anything you missed, okay, I'm going to make sure I put it online so you can watch it. Again, this one's pretty short. It's only like a 15, 20-minute video, but you can copy down anything you need. And you can use this sheet on the test on Friday. And we told you guys about the take-home, right?
Yeah.
So Thursday night, you're going to have 5 questions for a take-home. And then Friday in class, you'll finish up the test.